228 people just watched something cross 5 states that the leading expert tracking these events will not call a meteor. The fireball anomaly that started in March was supposed to fade by mid-April. It has not. And now 4 independent data streams, civilian reports, government detectors, asteroid tracking, and astronaut observations from beyond the moon, are all converging on the same conclusion. Something in our solar system has changed, and we can't fully explain it. Trust me, you'll want to stay until the end for this one. Let's get into it. On April 7th, 2026, at 2:34 in the afternoon Eastern Daylight Time, something streaked across the sky over the eastern United States in broad daylight. 228 people filed reports with the American Meteor Society. Witnesses across 5 states, Connecticut, Delaware, New Jersey, New York, and Pennsylvania, reported a brilliant flash of light and, in some cases, audible sounds. NASA logged it in their Skyfall database, which only includes events with more than 100 witnesses. Their analysis places first visibility at 48 miles above the Atlantic Ocean, just off the shore of Mastic Beach on Long Island. The object was traveling southwest at approximately 30,000 miles per hour. It covered 117 miles through the upper atmosphere before disintegrating 27 miles above the town of Galloway, New Jersey, just north of Atlantic City. Now, dozens of fireballs enter Earth's atmosphere every day. Most are grain of sand-sized particles that burn up in a fraction of a second. The bigger ones, the ones that produce visible streaks and witness reports, happen multiple times a week. This has been going on for 4.5 billion years. It is one of the most normal things that happens on this planet. But this one is different. Independent researchers who have been tracking the fireball anomaly since it began in March, analyzing dozens of events, building orbital models, cross-referencing government and civilian databases, reviewed the April 7th event and came to an unusual conclusion. They are not fully comfortable classifying it as a standard meteor or fireball. They believe that is the most likely explanation, and by a good margin, but they will not commit to it completely. That is the first time in the entire surge, which now spans weeks, dozens of events, and multiple continents, that the people tracking it most closely have hesitated on a basic classification. And when experts who have spent weeks immersed in fireball data look at an object and say they are not sure what it is, that is not a throwaway caveat. That is the story. So what made this one different? Multiple video recordings of the April 7th event reveal a fireball that behaves nothing like the March events. Start with the trajectory. Most fireballs arrive at steep angles relative to the horizon. That is what atmospheric entry looks like when an object falls into Earth's gravity well from interplanetary space. A lot of them come nearly straight down. The steeper the angle, the faster the object decelerates, the brighter the flash, and the shorter the visible path. That is the standard picture. This one did not follow it. It traveled almost exactly horizontally across the sky. It looked like something flying at high speed across the Earth, not falling into it. The visible path covered 117 miles, far longer than most fireball events, because the shallow angle kept it in the atmosphere longer before it finally broke apart. Then there is the vapor trail, or rather, the complete absence of one. The March fireballs consistently produced long, dramatic vapor trails that lingered in the sky for extended periods. Those trails are a signature of ablation, the outer layers of a meteor vaporizing from atmospheric friction. The material boils off, ionizes, and leaves a glowing column of gas that can persist for minutes. This object stayed tight. Almost no trail at all. Whatever it was made of, or however it was interacting with the atmosphere. It was not ablating the way a typical rocky or iron body ablates at 30,000 miles per hour. That could mean an unusual composition. Something denser, something with a higher melting point, something that resists ablation better than ordinary chondritic material, or it could mean something else entirely. And then the ending. Near the end of its visible path, the object appeared to slow down. It exhibited unusual terminal behavior, some kind of erratic motion before splitting into exactly 2 pieces. Fragmentation is common in fireballs. The thermal and mechanical stresses of atmospheric entry routinely break objects apart. But deceleration and erratic terminal behavior before fragmentation are not typical. Most fireballs that fragment do so suddenly. A structural failure under stress, not a gradual deceleration followed by erratic motion, followed by a clean split into 2. Natural variation in fireball composition, angle of incidence, and velocity can produce unusual-looking events. That is true. Fireball classification remains the most probable explanation for this object, and probably by a significant margin. But the uncertainty itself is the point. This is the most reported fireball of April 2026, one of the top 5 most reported events of the entire surge dating back to mid-March. And the independent researchers, who have been tracking these events more closely than anyone, will not fully commit to calling it a fireball. When the people with the most data and the most expertise hesitate on something this basic, you should pay attention to what they are seeing that is giving them pause. To understand why the April 7th fireball matters, you need the context of what has been happening since March. The fireball anomaly began in March 2026. The American Meteor Society confirmed it as real and statistically extraordinary, a 4.5 sigma deviation from the 2011 through 2025 baseline. To put that in perspective, a 4.5 sigma deviation means the probability of this happening by random chance is less than 1 in 100,000. The average number of witnesses per fireball event jumped from a prior record of 49.4 to 142. 79% of large events produced audible sonic booms, detonations loud enough to rattle windows and trigger car alarms. One major fireball was occurring roughly every 3 days. We covered the statistical foundation and the first off-world evidence in a previous video. But here is what has changed since then. There was an expectation, based on orbital mechanics, that if this surge was connected to the debris stream of interstellar object 3 I/Atlas, it should begin diminishing by mid-April. The logic was straightforward. Earth would transit out of the debris corridor, the encounter geometry would change, and the rate would drop back toward baseline. It has not dropped. April brought a 165 witness fireball over Europe, an 81 witness event, a 38 witness event, and then, on April 7th, the 228 witness eastern U.S. fireball that we just described. The geographic center of gravity of the surge appears to be shifting from North America to Europe, but North America is clearly not done. And barely 24 hours after the April 7th event, NASA's Center for Near-Earth Object Studies detected a preliminary 0.1 kiloton bolide over the Central Pacific, another atmospheric entry, another data point confirming the phenomenon is ongoing. That is a bolide-class event, an object that explodes in the atmosphere with the energy equivalent of 100 tons of TNT, occurring the day after the biggest fireball of the month. The anomaly is now conclusively global, at least 3 continents, North America, Europe, and Australasia, and it is not ending on the timeline that the 3 I/Atlas model predicted. Whatever is producing these fireballs, whatever is dumping material into the inner solar system, at a rate we have not seen in the modern era of observation, it did not stop when the model said it should. And that changes the entire conversation about what is causing this. This is where the science gets interesting. Monte Carlo simulations were run on the April 7th fireball, essentially modeling thousands of possible pre-impact orbits to determine where the object came from before it hit the atmosphere. You take the known trajectory, the entry angle, the velocity, and you work backward through gravitational dynamics to calculate the range of possible orbits that could have delivered this object to this point in space at this time. Every simulation run converged on the same result. The object originated from the far side of the solar system, the opposite direction from where 3 I/Atlas debris would be expected. That matters enormously. If the fireballs were coming from a debris stream deposited by 3 I/Atlas during its transit through the inner solar system, their back-calculated orbits should point toward the 3 I/Atlas trajectory. That is how debris streams work. The material follows roughly the same orbital path as the parent body, spreading out gradually over time but maintaining a directional signature. This fireball does not match that signature, and that means the direct interstellar debris stream hypothesis, the simplest and most elegant explanation for why fireballs suddenly doubled, has a serious problem. The emerging working model from independent researchers points to something they call a bulge off the asteroid belt, a higher density region of debris extending from the main asteroid belt into the inner solar system. Earth, in this model, is currently transiting through that region. The asteroid belt is not a clean ring. It is a chaotic zone of gravitational interactions containing material from multiple sources. Native solar system debris left over from planetary formation, material captured from the Kuiper belt through long-period gravitational dynamics, and yes, material deposited by interstellar objects like 3 I/Atlas over millions of years. All of it gravitationally mixed into a complex distribution that we do not fully understand. What caused this bulge to form or intensify? That remains unknown. Candidates include shifts in Jupiter's resonance dynamics. Jupiter is the primary sculptor of the asteroid belt, and its gravitational influence periodically ejects material through Kirkwood gaps and secular resonances. These ejection rates are not constant. They fluctuate on timescales of years to decades in ways that are difficult to model precisely. A collisional cascade is another possibility. If 2 large asteroids collided recently in the main belt, the resulting debris cloud would gradually spread along the collisional orbit. with fragments reaching Earth-crossing trajectories over months to years. There is also the indirect 3I/Atlas effect, not debris from the interstellar object itself, but the gravitational perturbation from its passage, destabilizing existing asteroid belt orbits, nudging objects that were previously stable into new trajectories that cross Earth's path. And finally, there's the possibility of an entirely uncharted debris stream from an unknown parent body, something we have never cataloged because we have never transited through it before. The mechanism is unclear, but the implication is significant. If this model is correct, this is not about one interstellar object leaving a trail. This is about a structural change in the distribution of material in our solar system, a change in the density of debris in the region of space that Earth moves through every single day. And that is a much bigger story. The fireballs are one data stream. They are not the only one telling the story. And while everything we have discussed so far has been measured from the ground or calculated from orbit simulations, the next piece of evidence comes from 250,000 miles away. And it was observed directly by human eyes. During the Artemis II mission on approximately April 6th, the crew witnessed a 57-minute solar eclipse from beyond the moon, the first solar eclipse ever observed by humans from that vantage point in all of spaceflight history. During that window, they observed something they were not expecting: 5 to 6 meteoroid impact flashes on the lunar surface. The impacts were near and south of the lunar equator and near the South Pole. The crew was reportedly thrilled by what they were seeing. This was not part of their mission plan, and it was not something anyone had predicted they would witness. That observation rate is anomalous. NASA's Lunar Impact Monitoring Program, run out of Marshall Space Flight Center since 2006, has cataloged roughly 300 confirmed impacts over 20 years. During established meteor showers, events like the Perseids or the Geminids, when Earth passes through known cometary debris streams, they typically detect 1 to 2 flashes per hour using sensitive ground-based telescopes aimed at the lunar dark side. During non-shower periods, the rate drops well below that. Early April 2026 is not associated with any major meteor shower. 5 to 6 impacts in roughly 1 hour during a non-shower period from a single human vantage point with the naked eye. That is not background noise. That is not a statistical fluke. That is a signal. And it is coming from an entirely independent measurement platform. The AMS measures fireballs entering Earth's atmosphere from the ground. NASA's CNEOS detects bolide-class explosions using satellite sensors. The Artemis II crew measured meteoroid impacts on the moon from a spacecraft in cislunar space. None of these systems are connected to each other. None of them share data in real time. And all three are saying the same thing. There is more material in the inner solar system right now than there should be. There is a fourth data stream, and it reinforces the same conclusion. Near-Earth object tracking data shows an unusual clustering of sub-lunar asteroid passes, objects coming closer to Earth than the Moon, within a compressed window. 3 asteroids have made or will make sublunar passes within roughly 2 weeks. Asteroid 2026 FM 3 passed at 0.62 lunar distances in late March. Asteroid 2026 GD passed at 0.65 lunar distances yesterday, April 9th. And asteroid 2013 GM3 will pass at 0.68 lunar distances on April 14th. For context, the average rate of known sublunar asteroid passes is roughly 20 to 30 per year, about 1 every 12 to 18 days. 3 in 2 weeks is approximately 3 to 4 times the average rate. Some of this can be attributed to improved detection. Surveys like the Catalina Sky Survey, Pan-STARRS, and ATLAS are finding smaller near-Earth objects at increasing rates every year as their sensitivity improves and their sky coverage expands. But detection bias cannot explain the fireball surge, because fireballs are observed visually by civilians with their own eyes, independent of any telescopic survey. And it cannot explain the Artemis II lunar impacts, which were observed by astronauts from a spacecraft with no connection to ground-based detection programs. The pattern is the same across all 4 domains. More objects closer to Earth in the same time window. Fireballs entering the atmosphere, bolides exploding with kiloton-class energy over the Pacific, meteoroids striking the moon, asteroids threading the gap between Earth and its own satellite, all of it spiking simultaneously, all of it pointing toward the same conclusion: there is more material in our neighborhood right now than there was 6 months ago. So let us put this together. 4 independent measurement systems are now converging on the same conclusion. The American Meteor Society's civilian fireball reports: rate doubled, 4.5 sigma deviation, global across 3 continents, with the most reported event of April occurring just 3 days ago. NASA's CNEOS bolide detectors: 5 bolide class events since March 17th. with a new preliminary detection on April 8th over the Central Pacific. Near-Earth object orbital data, 3 sublunar passes in 2 weeks at 3 to 4 times the average rate. And the Artemis II crew, 5 to 6 lunar impact flashes in 1 hour during a non-shower period, observed directly by human beings from beyond the moon. No single data source would be enough to declare that something fundamental has changed. Fireball rates fluctuate, asteroid detection improves every year. Lunar impact observations depend on timing and geometry. Each of these, in isolation, could be explained away as statistical noise or observational bias. But all 4 are telling the same story at the same time, using completely different instruments and methodologies. That is not a coincidence. That is convergence. And convergence across independent systems is how you distinguish a real signal from noise. The question is no longer whether Earth's cosmic neighborhood has shifted. The AMS confirmed it has. The question is why. The asteroid belt perturbation model provides the best working framework. A denser region of debris that Earth is transiting through, fed by a mix of native and captured material, potentially destabilized by mechanisms we do not yet understand. But nobody can tell you with confidence what caused the perturbation. Is it Jupiter's resonance dynamics, a collisional cascade, a delayed gravitational effect from 3I/Atlas, something we have not even considered yet? 5 bolide-class events detected by CNEOS since March 17th. A 4.5 sigma fireball deviation confirmed by the AMS sublunar asteroid passes at 3 to 4 times the normal rate. Lunar impacts during a non-shower period at levels that surprised astronauts. All of it happening in the same weeks. All of it pointing in the same direction. And nobody has a complete explanation. If the asteroid belt perturbation model is correct, if this is a transit through a higher density debris region extending from the belt, then it should eventually end. Earth will move through the region and out the other side. The fireball rate will drop. The sublunar passes will return to their normal frequency. The near-Earth environment will quiet down. But nobody knows how large this region is, how long the transit will take, or whether the density is uniform or increasing as we move deeper into it. If the model is wrong, if this is not a temporary transit, but the beginning of a longer-term shift in the near-Earth environment, driven by structural changes in the asteroid belt from 3I/Atlas gravitational perturbation or some other mechanism entirely, then what we have seen so far may be the opening act of something that persists for months or years. And the difference between those 2 scenarios is enormous. A temporary transit means elevated fireball rates for weeks, maybe a few months, and then a return to normal. A structural shift means the baseline has moved, that what we are experiencing right now becomes the new normal for the foreseeable future. We do not yet have enough data to know which one it is. There are specific things to watch for in the coming days and weeks. Asteroid 2013. GM3 passes at 0.68 lunar distances on April 14th, another sublunar event in 4 days. Does the European fireball rate continue or accelerate through the second half of April? Do the CNEOS bolide detections maintain their current pace, or do they drop off? The AMS will continue tracking. The data streams will keep producing numbers, and those numbers will tell us whether this is a peak, a plateau, or the beginning of a climb. What we know right now is this. Something has changed in Earth's cosmic neighborhood. 4 independent measurement systems, using completely different methods, agree on that fact. A fireball just crossed 5 states that the leading researchers tracking these events will not fully commit to calling a meteor. The surge was supposed to be fading by now. It is not. The orbital analysis points away from the original theory and toward something potentially larger, a structural shift in the asteroid belt itself. And we still do not have a complete explanation for why. We will be tracking this as it develops. The data is moving fast. The explanations are lagging behind. And as of right now, the phenomenon shows no sign of stopping. When it does, if it does, that will tell us as much as the surge itself. Until then, look up once in a while. You might see something even the experts cannot explain.